Code section 13.5 says problem solving using trigonometry. Yeah, we can solve some problems using this stuff. Let's see. It says a radio transmission tower is 83 meters high. Okay. Well, I don't know. Let me see. I'm going to draw my best radio transmission tower. And here it is. There we go. Kind of looks like an oil rig, too. What if I did like a beacon up there? All right, there we go. But I know that this height is 83 meters. Okay, got it. Now a support wire attached to the tower 25 meters from the top. All right. So there's a support wire. If the support wire and the ground form an angle of 42 degrees. Okay, so here's my support wire. Let me draw this in here. And it's 25 meters from the top. All right, so I know that this distance is 25 meters. So I can find out what this distance is in just a minute. Okay? What is the length of the support wire? Okay, so this is 42 degrees. And they want to know what this length is. What do I need the support wire length to be? Okay, well, let's find out how long this side is over here. Okay, since it's 25 meters from the top and the total height is 83 meters, then this distance is going to be 83 minus 25. Right? So 58, this is 58. Now here's what we do. Here's the critical part. I've got this right triangle here. Okay? Here it is. With the support wire and the height from the top of the support, where the support wire meets the tower, down to the ground, and this distance here. So I've got this right triangle here. Okay? And I know that this angle is 42 degrees. Now what is this side and this side to this angle, to 42 degrees? Well, it's the opposite, right, and the hypotenuse. Okay, well, which of the trig ratios do we know that involve the opposite and the hypotenuse? Well, that's the sine. The sine of 42 degrees is equal to 58 over x. Okay, now I can use my calculator to find out what the sine of 42 degrees is. Okay, well, let's see. Second pi, that brings me to the trig part, and when I want to know what the value is, I hit sine 42 parentheses enter. Okay, now I'm not going to abbreviate. I'm not going to round until it tells me to round. So the sine of 48 degrees is 0.669130606. The sine of 42 degrees. And that equals 58 over x. Now to find out what x is, I've definitely got to get it out of the denominator. So I'm going to multiply this side by x, and I'm going to multiply this side by x. Okay? So those cancel, and I'm left with 0.669130606x is equal to 58. Let's divide by 0.669130606 on both sides. 0.669130606. And I'm going to get that x is equal to, 58 divided by 0.669130606. And I get 86.67963994 meters. Now, did they tell me to round this to anything? They just said, what is the length of the support wire? Okay, well, they didn't tell me to round it, but this wouldn't really make sense for us to carry it out that far. Why don't we just go to one decimal place? I'm going to look at the number out behind it, and that's going to give me that x is equal to 86.7 meters, or it's approximately that. All right? Nice. Hey, the key part is realizing what these two sides are to this angle. Okay, it's opposite over hypotenuse. So we want to use the sine. All right? Let's look at the next one. Now, I do want to read over this because you do see it. The angle of depression and the angle of elevation. See, in this last problem, we have the angle of elevation. Because we're standing on the ground, the angle of elevation up to this point is 42 degrees. Okay? Now, let's see what this says. It says in surveying and navigation problems involving right triangles, the terms angle of elevation and angle of depression are used. Okay? In the diagram below, angle CBA, so that's here, 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 right? This angle right here. All right? Is an angle of elevation because here's the horizontal and we rise, we elevate up to this. So that's an angle of elevation. All right? Now let me get, well, I'll do a different color. Since the point A is elevated with respect to an observer at B. Okay. Angle DAB, all right, so that's here, to here, to there. So we're talking about this angle. All right. The horizontal line's here, and we depress to get the angle. Okay? So for the angle of depression. So angle DAB is an angle of depression since the point B is depressed with an observer at A. So if you're standing here, here's the horizontal, you have to look down the cliff or whatever you're looking at, right? It's an angle of depression, whether you're looking down or looking up. Okay? Now let's see if one of the examples gives this to us. Now this is a pretty interesting little problem because the World Trade Center obviously isn't there anymore. But we do have it in our problem here, and it says at a point 166 meters from the base of the World Trade Center in New York City. So here's the building. All right. The World Trade Centers were pretty monolithic. I mean, they were straight up and down. Lots of straight lines on them. Very interesting architecturally. And it says at a point 166 meters from the base. So let's just say 166 meters. Okay. Maybe you don't need to make it that long. Well, I don't know. Maybe about that long. Okay. The angle of elevation, so if you're standing here, right, you have to look up to the top, it's an angle of elevation, is 68 degrees. Okay, if I were on top of the building looking down, this would be an angle of depression up here, right? But they said angle of elevation, so I'm standing down here looking up. That's me. Okay, there we go. It says to the nearest meter, what's the height of the World Trade Center? Okay, well, they want to know, what's this length? Well, my question to you is, what are these two sides to this angle? Well, this one is the opposite, and this one is the adjacent, right? They don't have the hypotenuse in this one. So what are opposite and adjacent? Well, the trig function that deals with opposite and adjacent is tangent, okay? So what we've got is the tangent of 68 degrees is equal to opposite, which is x, over adjacent, which is 166. Good, now we just solve for x, right? So I'm going to type in, let's see, second pi, that gets me to the trig stuff. Tangent, all right, that's number 3. Hit enter, tangent 68, and I'm going to hit enter again, and that gives me 2.475086853 is equal to x over 166. Now we want to get x by itself, so I'm going to multiply both sides by 166, right? This one's a little easier than the first one because I can go ahead and x wasn't in the denominator. This cancels out, and I'm left with x is equal to, well, let's see, times 166. I'm going to get 410.8644177 meters. Now they didn't tell us what to round to. We'll just go to one place. Look at the 6, get rid of that stuff. And we're going to get that x is equal to, or approximately, since I'm rounding, approximately 410.9 meters. Because that is 5 over. Nice. Nice. That's a good problem. I like that. So at least I don't have to go to the top of the World Trade Center or the top of that building to figure out how tall it is. All right? Good job. Let's look at the next one. How many do we have? Let's check. That's 3. That's 4. Okay, just 3 and 4. All right, well, let's look at this. In a right triangle DEF. All right, I don't know what it looks like. I'm just going to draw it. There we go. All right. I will call this D, E, and F. There's the right angle. It says that DE is 16 and DF is 25. Okay. Oh no, it says E is the 90-degree angle. That's important. Okay, let me get rid of this stuff. I figured they'd let the last letter of the 3 be the right angle, but they said that E is 90 degrees. Okay, so we'll make this D and this F. All right. So it says that DE is 16 and DF is 25. All right. It says find the measures of angle D and F to the nearest degree. Okay. Well, let's think about this. I know. Let's figure out D first. Here's D. Okay. What are these two sides to D? Well, this is the opposite. I don't use the hypotenuse at all for this one. This is the adjacent. These two sides are the tangent. So the tangent of D is equal to its opposite side. That's going to be 25. Okay? Over the adjacent side, which is 16. So the tangent of D is equal to, I don't know, what is that as a decimal? 25 divided by 16 is equal to 1.5625. Okay? Now, for these, I don't have the angle. You see, for this one right here, they gave me the angle. It was 68 degrees, right? So I'm going to use regular sine. Here, they gave me the angle. It was 42 degrees, so I'm going to just use regular sine or tangent, okay? But now, they're giving me the value, and I need to find the angle. So now I need to use tan inverse. Whenever I'm looking for the angle, I need to use tan inverse. So let's do second pi. We'll go down, keep going down till you get to tan -1 and hit enter. And then you don't have the angle, so you type in the value, 1.5625, and hit enter. And I'm going to get D is equal to 57.3807569.3. And they said to the nearest degree. So I'm going to go like that and look at this number, scratch those things out, right? And I see that D is going to equal 57 degrees. Now the great thing is that this is 57 degrees. I know these two have to add up to 90, so this is going to be 33 degrees. Done. I only needed to find one to find the other. Okay? Nice. That's easy stuff. Now guys, I won't be able to do example 4 on this video, so I'm going to go ahead and stop it, and then I'll put the other video up there for you. All right, see you at the next video.